video. In this video, we shall discuss mass spectrometry. Mass spectrometry, which is also known as what? Mass spectrometer or mass spectroscopy. Mass spectroscopy. What is the meaning of what? Mass spectrometry? It's a device. Before I give you the meaning, let me quickly draw the device because I will use it in explanation how it works. When you have this is the device. When you have something like this, when you have something like this, when you have something like this, you have this, you have this, yes, this is what you have, this is what you have, this is what you have. Don't mind my diagram. Please don't mind my diagram because they can ask you to draw and label and with explanation. We have something like this, yes, okay. We have this. We have this. This place is what? Ether vaporizes then we have electron beam source. Electron beam source. We have entry of sample. Entry sample of sample. Okay, ether vaporizes sample. Yeah. Ether vaporizes sample. Then here we have this is what? Magnet. Magnet. Here there's what? Magnetic field. Magnetic field. Here is what? Detector. Detector. Then at this point we have two plates which are ion accelerated plates. They are made of what? Two plates, which are electric plates. Electric plates. Two of them together are known as what? Ion accelerated what? Plates, or which are ion accelerated plates, which are electric plates. Electric plates, which are electric plates. Electric plates. Okay, you have it. This is what? Mass spectrometry. And with this, I will explain how it works. Then what is the meaning of mass spectrometry? It's very simple. It is used to measure or calculate, to measure mass to charge. That means mass to charge, where M means mass, Z means what? Charge. Take note. Mass to charge what? Ratio of 1 or more samples or more molecules. Let me use molecules. Molecules in sample or in a sample. In a sample. In a sample. In a sample. Take note. That is that. Is there in your JUPEB question 215? Mass spectrometer is used to measure what? We have mass to charge ratio. We have charge to mass ratio. They gave another word, two options. The answer is for mass to charge ratio. Mass to charge ratio. It is used to measure mass to charge ratio. Take note of this. The device employs ionization ionization. It employs ionization and mass analysis. And mass analysis of a compound to determine the mass. Yeah, you can use it to determine the mass, the formula and structure of a compound. Take note. That is another word, meaning of what mass spectrometer, and that is one of the word application of the word device. It employs what ionization and mass analysis. That means for you to determine the molecules, the structure, the formula of the word of the molecules, or the isotope of the molecules, the sample must be ionized. Take note. It employs what ionization and what mass analysis. Mass analysis. When we get to this stage, you will see how it is used to determine what mass. How is being used to analyze what mass of a sample. Take note. It employs what ionization and mass analysis of a compound or of a sample to determine the mass, the formula, and the structure of the word sample of the compound. It can be of an element. Take note of that. Then the next thing is to look at what how it works. How does this device work? How does it work? For it to be simple, to make it simpler, I will divide how it works into our 4 stages. The first stage, I will call it what? Ionizer stage. That is the first stage, ionizer stage. The second stage, I will call it what? Accelerator stage. The third stage, I will call it what? Deflector stage. While the fourth stage, I will call it what? The detector stage. Detector stage. Then how does it work? How it works. How it works. The first one, number 1, ionizer stage. Ionizer stage. Ionizer stage. I will use this diagram to explain that. Please look at it. Ionizer stage. This is the entry of the sample. The sample or the molecule you want to analyze will pass through this. Then it will come to this point. At this stage, I will use these 2 things to explain. 2 things are involved. What the first thing at this stage? The ether vaporizes sample. This ether will what? Eat the sample. The ether will eat the sample. When current is passed, the ether will eat the what? Sample, and the sample will be vaporized. The ether will eat the sample, and the sample will what? Will be vaporized. Take note of that. Then after that, the vaporized sample will now be what? Be bombarded with what? Electron. And the electron must have what? High energy. The vaporized sample will be bombarded by what? High energy electron. The function of this electron beam is to bombard the sample by high energy electron, so that the sample can be what? Ionized. So that the sample can be what? Ionized. Take note. That is the first stage. That is ionizer what? Stage. At the ionizer stage, what will happen? 1. The sample will be heated. Will be what? Heated. Will be heated. And vaporized. By this, ether vaporizes sample. By ether vaporizes sample. Take note of that. When current is passed, that is the first. Then, at the first stage again, what will happen? This electron beam will produce high energy electron that will what? Bombard the what? Bombard what? The sample. The vaporized sample or the heated sample. The electron beam will provide what? High energy electron that will bombard the heated sample. That means, another point, the electron beam will produce high energy electron that will bombard the vaporized sample, so that electron is knocked out of the sample, so that electron is knocked out of the what? Sample. Then when electron is knocked out of the sample will be ionized. The sample will be ionized. That is it. That's what will happen in the first stage. That is what will happen in the first stage. Please look at it. That is what will happen here. That means ionizer stage. That is what will happen. The first thing, the ether vaporizes sample will eat the what sample. It will vaporize. Then electron beam will produce what? High energy electron to knock electron out of the sample so that it will produce ion. It will be ionized. The electron will bombard it to knock out electrons so that it will be ionized. Take note. Then what will happen? The ion will now be accelerated through the ion accelerated plate. That is the second stage. Let us go. Pause the video and write this out. You can pause the video and write it out. It came out in JUPEB in course. It came out in JUPEB in course. You can pause the video and write it. Please pause the video and write it. Thank you. Let me rub it off. Rub it off. Rub. One love. Rub it off. Rub it off. Rub it off. Rub it off. Rubby. The second stage is known as what? Accelerator stage. That is this stage, accelerator stage. What will happen? The ion will be accelerated through the what? Ion accelerated plate, which are what? Electric plate. That means it will move. That means it will move. It can be called, it will move. It will move. These are the what? Ions. That means at this stage, what will happen? These electric plates, they are charged plates. They are what? Charged plates. The positive ions will be repelled by the positive charge plate. Take note. The positive ions from the sample will be repelled by the what? Positive charge plate. Then the acceleration that will happen here, the acceleration can be controlled by adjusting the charge on the what? On the plate. Take note. The acceleration that will occur here can be controlled by adjusting the what? The charge on this what? plate. Don't forget, they are electric plate. That means they are charged plate. Then the positive charge plate will repel the positive ion, or like charges attract, like charges repel. Because we have positive ion, the positive charge plate will repel the positive ion. Then the acceleration can be adjusted, can be controlled by adjusting the charge on the plate. The acceleration can be controlled. That means if you want high acceleration, you will control the charge on the electric plate. Take note. That is, at this place, what will happen? The ions, the first one, the ions will pass through. We pass through ion accelerated plate. Which are what? Electric plate. Which are what? Electric plate. Electric plate. Another thing, what will happen? The positively charged ions will be repelled. Yes. Will be repelled. Yes. Will be repelled by positively charged plate. Yeah, positively charged plate. Take note. And what will happen? The acceleration that will occur at this stage can be controlled. Yeah, can be controlled by adjusting the charge on the plate. Yeah, the charge on the plate. Yes, take note. That is what will happen at that plate. Then the next stage, which is the third one, you will always see question now. That is what this separation stage, which I can also call what deflector stage, which is also known as what the separation stage or separator stage. Please, you can pause the video and write it. You can pause the video and write it. Let us go to the third stage because I brought this one up. You can do that before we go to questions. Thank you. Let's move. Yes, let's move. We are here to give you the best. Ace in JUPEB, 300 plus in JAM, Ace in WAEC. We are here to build you from SS1 to SS3. We want to build the best. There must be best in this country. Our science student must be what? Must be perfect in this country. They must be perfect. We are here to build the best in this country. Let's move. What is the third stage? Number 3. I call it the deflector stage or separator stage. Very big stage. Yeah, I told you at this stage we have a magnet that produces what? Magnetic field. A magnet that produces what? Magnetic field. What happens? They accelerate this magnetic field. The ion sample or sample ion accelerate to the magnetic field. Then what will happen here? Take note. This is where they will be separated. How are they separated? They are separated based on their mass to charge ratio. They can answer the question. They are separated based on their what? Mass to charge ratio. What will happen? At this stage, heavy ion will be deflected less. Take note. Heavy, the ion that is heavy will be deflected less. That is how you know. When you see the one that is deflected less, you know that this one is heavy. That means has higher mass. Has what? Higher mass. The one that is what? Light ion will be deflected more. When you see the one that is deflected more under this magnetic field produced by a magnet, you know that that one is what? Light sample, light ion. The ion, let me repeat myself, the ion that is heavy will be deflected less in the magnetic field. The ion that is light will be deflected more. I told you they are separated or they are deflected based on their mass to charge ratio. Based on their mass to charge ratio. Take note of that. They are deflected based on their what? Mass to charge ratio. The one that is what? Heavy will be deflected less. The one that is light, the ion that is light, will be deflected what? More. Another thing. The ions that has more charge, maybe +2, +3, will be deflected more. Take note. I will write it down. The ions that has more charge, maybe +2, +3 charge, will be deflected more. And the ion that has less charge, +1, will be deflected less. Let me write it down. That means at this point, they will be what? Separated or deflected based on their mass to charge ratio. Then, heavy ion will be deflected less. That's it. Light ion will be deflected more. Take note. That is one. Another one. Ion that has more charge. Let me say 2+, 3+, will be deflected more. I will explain. Ion that has less charge, maybe +1 or 1+, +1 or 1+, will be deflected less. Will be deflected less. Take note of that. Take note of that. Please take note of that. For example, look at this. Look at this. When you have copper plus, copper 2 minus, in this case, which one has more charge? This is sample B, sample A. Which one has more charge? This one has more charge. That means this one will be deflected what? More. This one has less charge. This one will be deflected less. Okay, let me give another one. When you have copper, the same charge, let me assume the same charge. This one is, let me assume 63. This one is 65. That means this one is heavy. This one is what? Light. Why? Because the mass of this one is what? 65. The mass of this one is what? 63. This one is heavy. This one is light. This one will be deflected what? Less. Deflected less. This one will be deflected what? More. But this one has more charge, will be deflected more. This one will be deflected what? Less. More charge will be deflected more. Less charge will be deflected less. Heavy will be deflected less. Light will be deflected what? More. Take note of that. That's what we have. I call it separator stage. That's how to separate them. Then what happened? The next stage, they now move to the word detector. Detector. That is where the isotopes are obtained. This place, what will happen? The ion that is more. When you see a particular ion that is more, that means it has more relative abundance. Let me assume this one is more here. It's more. You have more of it here. This one is just few. This one is P. This one is P. This one that is more here, we have the highest relative abundance. We have the highest relative abundance. Take note. We have graphical representation of this. Here, the analysis we done. How do we represent the graph? That question came out 2021 JUPEB. They give you graph. They want you to calculate the graphical representation. That means I've explained the detector stage. We get the word where we determine the word, the isotope or the sample with the highest relative word abundance. Take note of that. Where we determine the sample with highest relative word abundance. Then let's move to the graph. Let's move to graph. 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 Where you have this? The graph. We have relative abundance is at the vertical y-axis. Y-axis. Relative abundance. 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 Relative abundance, which is given in percentage. Then at this point we have mass to what charge ratio as what S-axis. Take note, they can ask you or here will be given as what atomic mass unit AMU, or you can have AMU here. This is graph. Then what will happen? You have one sample like this. You can have another sample. You can have another sample like this. Now depends. That means relative abundance of this one can be, let me say, 60%. Relative abundance of this one can be what? Let me say 10%. The relative abundance of this one, let me assume, can be what? 30%. 30%. Then what we have here is the atomic mass unit of this one can be given as 76, 78, 79. Or they can give you a mass to charge ratio. Take note, atomic mass unit or mass to charge ratio are S-axis, while the relative abundance is what? Y-axis. Take note of that. Look at this question. Let me quickly give you this question before we go to the one in the past question. Let me give you this. Let me quickly give you this question. In mass spectrometer, in mass spectrometry, which of the ions, reach detector, reach what? Detector first. Which of the ion which in mass spectrometry, which of the ion reach detector what? First. With explanation. First. With explanation. This one is first impulse. First impulse for JUPEB. The first question where you have CH4 plus 12, CH4 plus 13. You have the second one. You have bromine plus 79. You have bromine plus 80. You have 81. 81. 81. Let me add this one. I can add this one. 3. I can add cobalt plus 2. Cobalt plus 1. Let us look at this. Which one of them will reach the detector first? I told you, the one that is light will be deflected more. The one that is what? Heavy will be deflected less. The one that has more charges will be deflected more. The one that has less charges will be deflected what? Less. Look at this. They have the same charge. But the mass of this one is what? 12. The mass of this one is 13. Which one is heavy? This one. Which one is light? This one. That means CH4 12 will reach the detector first because it is what? Light. It will be deflected more. Just like explain because it is light. That is your answer. it will reach the what? Detector first because it is light. Let's look at this one. Again, the same word charge. The mass of this one is 79, the mass of this one is 81. Which one is light? This one. That means this one too will reach the detector word first because it is light. That's the reason, the explanation. But look at it. Look at this. The charge of this one is plus 2. The charge of this one is plus 1. Which one has more charge? This. That is, this one will go deflected word more. That is, the cobalt 2 plus will be deflected more. We reach the detector 4 because it has more charge. Okay, let us look at question from your word JUPEB. Let's look at question from your JUPEB. Let's look at question. Let's continue. Look at this question. Let's do this question. This is JUPEB in course. When a sample, this very simple. I won't write it down, just explain to you. When a sample of copper is analyzed using a mass spectrometry, its atoms are ionized, accelerated, and then separated. 3 stages: ionizer stage, accelerator stage, deflector stage, that is separated stage. According to their mass to charge ratio, mass to charge, they use E here, I use Z. It's the same thing, mass to charge ratio. Explain how the atoms of the sample are ionized. How is the sample ionized? Very simple. Go back to the ionizer stage. How are they ionized? The first thing, the sample will be heated. Should I write it down? Let me, the first, for the Roman figure 1. For the Roman figure 1, please write the question. Then, how are the sample ionized? They say the sample is for copper. The sample is for copper. Then, how are they ionized? How are they ionized? That means, for the first question, how is the sample or atoms ionized? How are they ionized? The first one, the sample or the atoms will be heated, and vaporized by ether vaporizes sample. It will be heated and vaporized by ether vaporizes sample. That's the first one. Then the second one, the atoms will be bombarded by high energy electron, to knock out electron from the atom so as to ionize. Take note, that is it. Electron will be produced by the what? Electron beam source to knock out electron from the atom so that it will be what? Ionized. Then the second question, state how the resulting ions are accelerated. Very simple. How are they accelerated? How is the atoms or the ions now accelerated? How are they accelerated? That is accelerator stage. The ion will be passed through what? Ion accelerated plate. Please let me give it to you. You can follow me the way I'm giving you the answer. The ion will pass through what? Ion accelerated plate, made up of 2 electric plates. Then what will happen? The positively charged copper will be repelled by the positive charge plate. And the acceleration can be controlled by adjusting the charge of the plate. Very simple. Let me repeat. Answer to the second question. How is the ion accelerated? The ion will pass through what? Accelerated ion or ion accelerated plate. The ion will pass through ion accelerated plate made of two what? Electric plates. The positively charged copper will be repelled by what? Positively charged plate. Then the acceleration will be controlled by adjusting the charge on the what? On the plate. That means acceleration will be controlled by adjusting the charge on the plate. That's how they will be accelerated. To increase the acceleration, adjust the charge on the plate. To reduce it, you adjust the charge on the plate. Then the third one. State how the ions are separated according to their mass to charge value. Very easy. The one that has higher what? Mass. Heavy. That means the one that is heavy will be deflected less. The one that is what? Light will be deflected more. That's it. The copper that is heavy will be deflected what? Less. The copper that is what? Light will be deflected what? More. Or the copper that has more charge, will be what? Deflected more. Then the copper that has less charge will be deflected less. Take note of that. You've answered the question. Very simple question. Very simple. You've answered it. Very simple. Very simple. Let's go to the next one. We've answered it. Let's go to the next one. Let's go to the next one, please. Let's go. For a particular sample, of copper, 2 peaks were obtained. That means 2 isotopes were obtained in mass spectrum, showing an abundance of these when the what? Mass to charge ratio, that means the mass to charge ratio, that means atomic mass, 63. And the relative abundance of the second one, 30.90, when the what? The mass, the mass of this one is 65. When the mass at 65, the mass of this one should be 65. Yeah, the mass of this one at 65. Then give the formula of the species responsible for the peak mass to charge ratio of 65. The formula of that sample they've given you is for copper. See, copper. That's why they want you to write chemical symbol for copper. See, that is the first one. Give the formula of the species responsible for the peak mass to charge of 65. The sample is copper. They just say the formula, chemical formula of copper. See, don't write copper. Don't write copper like this. They ask for the chemical symbol. See, just like see. It's the chemical symbol they ask for. See, if I answer that, it's very simple. Then the next question. See, don't write copper. COPPER. They say the chemical formula Cu copper. Then the next question is what? State why 2 peaks at N to E mass to charge value of 63 and 65 were obtained. Very easy. The answer to this question, write it down. State why 2 peaks at mass to charge value of 63 and 65 were obtained in the mass spectrometry. Why? Because the time to cover this distance from the ionizer stage to the detector stage is very short. That's the answer. The time to cover the distance from the ionizer stage to detector stage is very short. Take note of that. The time to cover the distance from the ionizer stage to detector stage is very short. That is why we have 2 peak of 63 and 65. That time for copper is very short. Then the next one, Calculate the RAL, that means relative atomic mass of this sample of copper using the data. These are the data. Very easy, very easy. I told you relative atomic mass equal to mass number of the first isotope, relative abundance, plus mass number of the second isotope times relative abundance over 100. In this case, what is the first isotope is mass is 63, relative abundance is 69.1, that is relative atomic mass is equal to mass of the first isotope 63, relative abundance 69.10 plus mass of the second isotope 65 times relative abundance 30.90, everything over 100. You can solve the rest. You can solve it completely. Solve it. Very simple. Please complete the solve. Then let's go to this one. 2021 JUPEB question. 2021 JUPEB question. Number 2021 number 8. Yeah, should be number 8 or number 9. 2021. This is the graph of what? Mass spectrometer analysis. That's the graph. Let's solve it. Very simple. 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 Look at this. I told you relative abundance is y-axis. Atomic mass unit or mass to charge ratio is what? S-axis. S-axis. Y what? Y-axis. 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 Then what we have? This is the first isotope. The analysis of the first isotope. What is the mass? The mass, atomic mass unit, the mass is what? 70. That means, let me have M1 is what? 70. What is the relative abundance? 70%. Can you see it's in percentage? S1, 70%. The second isotope, mass, M2, is what? 75. The relative abundance is 10. That means in percentage, S2, 10%. The N3 is what? Mass is 78. The relative abundance, 20%. If you sum up all the relative abundance, it must be 900. 70 plus 20, 90 plus 10, 100. It must be 100. It's 100. Then they say the mass spectrometer of an unknown element is displaced above. The atomic mass of the element is, that is relative atomic mass. Relative atomic mass unknown. Which formula? The same way, AR equal to M1 H1 plus M2 S2. This one we have 3 isotopes plus M3 S3 over 100. Substitute all those data. AR, M1 is for 70, S1 is 70, M2 is for 75, times S2 is what? 10, plus M3 is what? 78, times S3 is what? 20, everything over 100. 70 times 70, 75 times 10, 78 times 20. You can solve it. Please, you can solve it on your own. Please, for more video, subscribe. You will see a link down the comment or down the video. If you need physical classes or online classes, you can call any one of those number, any one of those 2 numbers, which are admin. You can call them for physical or online classes. 100 level student, medical student, physical sciences, biological sciences, engineering, we are here for you. The math will be taken care. Your engineering math will be taken care of. Medical student, your botany, zoology, microbiology will be taken care of. Your biology will be taken care of. Your chemistry, physics. JAM student, we are here for you. Biology student, from SS1 to SS3. I remain myself, JAM.